Okay, welcome everybody for this talk. Thanks for coming. So we'll be talking about 20-year-long vulnerability. My name is Olgierd. I work for security architecture in Oracle. I help our teams to write secure code. And I will be talking about code security. So the flow of this talk is quite unusual. We'll do a lot of zooming in. We'll zoom in quite hard into this problem, and then we zoom out to understand what we can learn from that. So at points it will be a bit hard, but then at the end it will become very obvious, I hope. So we start with zooming into web applications, then we look in Apache Struts, which is our subject here, and how it handles parameters. And we'll discuss some vulnerabilities. And then when we zoom out, we look at some technical challenges, the slippery slope, how people deal with abstractions, and what we can learn from vulnerability reports and their quality in some places. I will lie just a bit. So if you're like an expert on Java, you will find that there's some poetic license in some of the examples. There is a contained space, and those things are complex. So this wouldn't hinder. It's factually correct, but there are some simplifications. So don't tell me that, oh, this is different. I know. Okay, so web applications. From the very top, web applications just work by request and responses. You, as a browser, send a request. Application sends a response. If we zoom in, there is actual protocol there, HTTP, which deals with, which supports that. And with HTTP, you have certain formats and conventions and protocol, how it's being used. In particular, for example, parameters are sent in this encoded fashion. The responses are sent with the protocol, and typical response is HTML. So, very early when we started building web applications, we've been dealing with all of this by hand. So, like if you remember CGI bin, and like if you were writing web applications in Perl, like half of your application was like dealing with this encoding and breaking things and decoding them, and then your code would be half of your logic and half of like outputting HTML to the standard output, and that's how it was done at the very beginning. But luckily, over time, we developed frameworks. We wanted to shift the balance from handling all of this request and response and focus more on application logic. We wanted to write actual applications, not deal with all this legwork of handling requests and responses. And that's where we are now. We don't deal with that. We use those frameworks. And the framework I will be discussing is Apache Struts. Struts was groundbreaking in a way that it really helped building applications in a modular fashion using high-level language in Java in reusable manner. And at that time, it was, I think, like 75% of Fortune 500 companies used Apache Struts. So it was very, very popular. It still is. So Struts uses something like model view controller paradigm. In a nutshell, oversimplifying a bit, it separates the logic into controller, which is Struts, that handles all the legwork, requests, responses, and parsing. And what you do as application developer, you write actions, which are the model part, where your business logic lives, and view, which is the presentation, the HTML part, the JSP, whatever. So you can separate that. You can have different team doing the business logic coding, a different team doing layout. You don't mix one with another. So example of an application is all of this. I will be talking about like a simple function that returns an order, right? So if you have like an online store, you want to get an order by ID. That part of logic of this application will be covered here. So implementing something like this in Struts, as you can see, there are two pieces. There is this action, and there is a view. Action does very simple things. It implements three methods. One is to set the order ID. This is how the action will get to know what order it is asked about. There's execute, where the actual logic happens. This is where it takes the order from database, for example, and returns success, which tells Struts, okay, this worked, I can render the view. And it provides a getter for order, which allows later part of the application logic to retrieve it. So if we try to look what happens actually when Struts works with an application, the browser sends a request. This is handled by Struts. My code doesn't run yet. Then Struts goes and instantiates my object. It calls setOrderID on that. So my object receives that. I can remember it for later. Then it calls execute. Then my logic runs. Then it knows that it wants to render the view. It renders the view. And in this view, there are some special Struts tags. So the HTML part can refer to the value returned by action. So this is very nice because I can, as you can see, the left-hand side part has not, it doesn't really do anything related to web. It's a pure logic. It sets, gets, it doesn't deal with any parameters. It doesn't deal with any presentation. You can go and swap those views. You want to return JSON, fine. Your logic stays the same. You can just replace those views. HTML goes back. So now we're getting to the actual core of the problem. What is this magic? How this happens that when request has order ID, Struts decides to call my action setOrderID. I can name things however I want, and those things will happen. And this magic that Struts uses, it's called OGNL. OGNL is a library that allows you to kind of traverse and address Java objects and hierarchy of Java objects as strings. So you have all these things we can say, like foo, we'll call get foo on an object. If you have foo equals bar, it will set foo to bar. And you can chain things, you can access lists. It's pretty powerful. You can do a lot of things with that. So you can have simple strings on one side and have like Java operations on the other side. So this is what Struts is using for that piece of logic. So your parameter gets interpreted as OGNL. OGNL parses that and executes the method. This piece is pretty nice because I don't have to go and configure everything. I just have this magically working with my application. Unfortunately, this logic was responsible for this many vulnerabilities. I'm happy that there is not one more because it would look nicer. So those are all the vulnerabilities related to OGNL processing by Struts. It's not all the Struts vulnerabilities. And they were what we have many years of those vulnerabilities, and some previous problems were not reported as CVE, so they don't have records. I will cover them. So what I did, I spent weeks going through them, going through every code change after code change, every discussion on mailing list or in Jira, looking at every bug report and how it was reported. And I was trying to understand how this happened, how that one piece of code could have resulted in so many problems for so long. So we will zoom in even further to those vulnerabilities and see what we can learn. By the way, those vulnerabilities were pretty, I will not show all of them, but this is what they were about. This is the description of all the vulnerabilities. As you can see, many of them were remote code execution vulnerabilities or vulnerabilities that allow you to modify internal state of an application and compromise it. These were pretty severe vulnerabilities. Okay, so let's talk about OGNL. So, first thing, OGNL does more than Struts uses it for. So with OGNL, you can do things in the middle. If you see, you can you can write things such as execute Java, and OGNL will do this for you. So if you put this whole thing into a parameter, it will go and run your code inside that application. Luckily, very early, Struts team has disabled that functionality of OGNL, so they just disabled method execution altogether. Okay, so that worked fine. Another problem was that it has something called context variables. So you have variables in Struts, in OGNL. They are denoted with hash. And coincidentally, Struts also uses this stack of variables to store information about the state of application, such as session and user information and internal state. So you can just use that convention in OGNL and, like, for example, set user to admin in your session just by using OGNL and the fact that Struts uses that OGNL. So when Struts saw that, they implemented a fix. And that fix was, hash character is a problem. We will have a filter that says if your name has a hash. So like in Java, this means if it contains. If the name contains hash, then reject the parameter. But then it was discovered that there is more you can do. And then it was discovered that you can use Unicode version of hash. So they kept adding those things. They decided maybe that is not good, so they put a regular expression instead. And that worked for a while. Then it just was discovered again that you can manipulate that. So that filter wasn't perfect. And you can do actually two things. First, you can bypass that by putting this as a sub-expression in Struts. In OGNL. So that's the bracket. But also, the logic that controls that method execution is disabled, so you cannot write in your custom code, was also controlled by custom variable. So first you bypass that, you enable method execution again, and you're back to business. You can execute custom code on an application from the browser. So they expanded this regular expression to remove that. But there was more. So there was, you could run static methods. So dynamic methods were disabled. Static methods, things that are always existing in the system, they don't refer to any specific objects, were available. So they had to disable that. You could run constructors, which was pretty interesting because some constructors have side effects. So for example, if you run a file writer constructor, it creates a file. So that was available. And you can put OGNL inside OGNL, and that was also available, and you could bypass that filter this way. So they were refining and refining and refining that expression to this point. But there was another problem. So before I go there, kind of thing to have in mind for the beginning. There was another problem that people use request parameters for other things than talking to application. In particular, there was a popular framework called Dojo at the time. And Dojo was using parameters to just denote that the page has a different URL to bypass cache. But those things didn't have a corresponding methods and they were causing errors. So there was a request put for Struts to disable certain patterns of parameters so they are not used. This is not for security. This was just so the errors don't show up, right? Because many pages, if they use particular JavaScript framework, will have those parameters added, but they have no use in the application. They are just internally there. So what they added was this, again, not a security mechanism. It's just a convenience that certain parameters were just excluded and not considered in that processing. Let's just park that for a moment. Okay, so another thing in Java is that it uses inheritance. Inheritance is that you implement an object, you can implement an object on top of that object, or underneath that object, maybe better. And that object inherits that behavior. So you can have parent object, it has getFoo method, and you implement child object, which has getBar, but the child object also has getFoo. It's like an extension of that other object. And that's in object-oriented programming, that's That's one of the main things, right? People do this all the time. But also Struts has some of those parent objects that you can use to tell Struts that your action is interested to receive certain things, right? So for example, if your action is about to see session, as you can see, this is just a plain Java object, you implement that interface and create set session in your class, and then Struts knows that it has to pass you a session. So your class action implements session aware, and it has this set session method added. Now, this caused a problem because now you have a conflicting feature. One is you want to see session, but the other one is you added a public method that OGNL can interfere with. This is just because your class added that. It didn't have it, it just has it now. So that was a problem. And when they decided to fix it, but this is not specifically about OGNL. This is just, it's a method that is in the class, but like we don't want that one. So this is when they decided to reuse that feature they had for just like convenience now as a security mechanism, and they added all of the things that their interfaces that were provided with Struts were implementing. So they promoted this non-security feature to a security control to add that. Okay, so that worked for a while. But there was another problem. In Java, every class inherits from object called object, from class called object. Like this is like a root object of everything. And that class has certain methods, like getClass, toString, hashcode. If you know Java, you're familiar with that. So these are like things that every class has implicitly. So the problem is that if you have getClass, which is publicly accessible, getClass has class loader underneath itself, and then you are just limited by your creativity how you can exploit that. So the point is that through these public getters of through public interfaces of every object, you can go and manipulate things like state of JVM. So there were very creative attacks based on that, where people were like stringing multiple requests one after another to modify the state of JVM to run custom code. So what Struts did? Okay, so they added that. There was a couple of iterations of that regular expression because it wasn't really always working well. So as you can see, this expression got a bit complex, but they again added that to the list. And they were modifying that. So there were new problems found. This set of filters was not good. People were finding ways around them. Then like they compressed it and expanded it. So this is what I think at the end is in Struts today. I don't know what it's doing that much. Like I could spend some time and understand, but this is complex. This doesn't look good. So are we done with OGNL? Well, almost. So at the same time when all of those was happening, there was another logic in Struts, which was Cookielnterceptor, which was doing exactly the same thing, just for cookies rather than for parameters. And only very late it was discovered, oh, actually it has all the same problems, so this was added there. So many of those CVEs refer to cookies as well. Cookielnterceptor also has its own pattern, and that was added and solved some of the problems. Okay, so this dragged on for like 20 years. What went wrong and what we can learn? That's where we will be zooming out a bit. So first of all, on very obvious but very superficial as well. Like, don't do regular expressions for security. This just doesn't work. They are hard and they are difficult to manage. In fact, some of the vulnerabilities were just based on the fact that while making some fix, developers broke those regular expressions. So they disabled previously filtered things. So they messed them up themselves by accident. Here is an example when they just removed something by accident and they had to put it back. If we go further, so this is pretty interesting. So this is all the changes to all of those filters across all of those years. And when it's bold, it denotes that, like, what was the actual change. So this is very interesting to look at that from that perspective, because it's very easy to pick on developers and say, why you did that. And if you look at the final set of regular expressions, yeah, this is pretty mad. But it didn't happen this way, right? So at the beginning, what happened was that there was pretty simple problem and pretty simple solution. And then when the new problem appeared, the natural thing was to extend existing solution. And the more that existing solution was expanded, this became like default mechanism for doing that. So when the developer is told about vulnerability that lots of websites and companies are angry about, and they have to produce a fix as quickly as possible, they naturally would gravitate to just extending the solution they already had, even though it creates this very complex logic that is not very good. There were hints where things could have been changed. So, for example, moving from just list of conditions to regular expression, or refactoring regular expressions. That happened a couple of times. But yeah, there was never a good time, because the right incentive to do something about it is when you're making change. But this is also when you had to make as quick change as possible. So perhaps choosing simple solution at the very beginning is the real danger, because it puts you on the slippery slope. The right time to redesign it is probably earlier, because the longer you go, the more you have like people depending on it and so forth. There's more to that, because this changes were split between config, users can overshadow them, and there was much more complication in that. But yeah, making early decisions to fix problem in a particular way will haunt you later on. So if we zoom out a bit more, the other problem that you can observe is that what Struts did was they used existing convention of like public method. Public, so access modifiers for fields. You can have methods that are public, private, protected. These are not security things. They know they sound security, but they are not. They are just about kind of defining interfaces and how things get exposed across between objects. What Struts did was they mixed that convention that is used for many other purposes. And people do use public methods because they have to, because they want to have their classes extendable. But they linked it with, you can set parameters if a method is public. And they created this new thing that any public getter and setter is accessible by HTTP request. This is unexpected. This is implicit. This is this magic that this service, that this framework provides. But it's very unexpected. And many of the problems result from that. What they should have done, and what other frameworks did, like Spring, is that making it explicit. So don't hijack the concept of public methods and use that for a decision. What Spring does, it's a similar logic here. It actually has ways to tag things. So you say, oh, I wanted this to be a parameter, and you can even name it differently. It's not implicit, it's explicit. So everything else stays invisible to the world unless you explicitly say, I want this thing to be visible. Funny fact, in one of the discussions very early, Struts were considering that. So developers of Struts were like, you know what, we should have this annotations, those things that are here called annotations. We should have these annotations to solve that problem. That never happened. This was 2007, so this was very early. This was this opportunity to fix this problem once and for all, but unfortunately it didn't happen. So if we zoom out even further, probably the core problem and the things that we should avoid in writing software is when we have a need and we look for a solution for that need, we need to find one that has all the things that we need. But what they have chosen is something that does that, but also much more. So using too powerful tool is, in this case, dangerous. They didn't need to have the full expressiveness and full capability of OGNL, but they use it because it was close, it was from the same umbrella, the same ecosystem, and it was convenient for them to use because it had all the things they needed. Now, if you discover that, oh, I have a tool that does more, but now you have all this behavior that you don't want inside your code. So what do? Well, they try to contain it. So trying to take something that is much bigger than you want and trying to contain it through some sort of firewall doesn't really work in software. So this is false dichotomy. This is false equivalence. Those things are not the same. The expectation is that they will be the same, but you don't build smaller things by taking bigger things and just slapping protections around it. That's the main problem of this design. So another thing that we could see is that, so in software we always build larger things from smaller things. Nobody writes software from scratch. We use components, abstractions. And it's great because it reduces the complexity. That's the idea. You have to reduce the complexity. You delegate some task to some other abstraction. So this is our kind of Struts application. So it has your app. The app can use some library. You have your Struts. It has all of those components. You have OGNL. It does things. And you have Java underneath all of that interacting with everything. You have web server, internet. It's a very simplified model, but it already looks complex. The problem is that this wasn't a clean abstraction. It was like everything was interacting with everything else in unpredictable ways. Rather than reducing complexity, it was actually increasing complexity. So when we, in hindsight, look at that problem, it's like, oh, setting a particular parameter through Struts to OGNL allows you to take advantage of class loader that is on every object. This goes all the way through all of those layers. And it's not a clean abstraction because of that chosen way of running code but trying to contain it. Another problem is from a point of view of developer who sits in particular place, it doesn't look this way. We see it this way because we analyze this all, but what developer sees is something like this, right? They still see those abstractions. They don't see all the details of all these complex interactions because they want to see that. They know a bit about Struts, but maybe things get blurry at the edges. They know that there is some expression parsing in OGNL because that's what it does. And they knew very early that there is method execution that they disabled and access modifiers in Java because that's what they used. But that's it. And only later, when the reports of vulnerabilities were showing up, they gained understanding of those things that were invisible, but again, never get probably full understanding because, okay, this is very simplified model. They just see bits and pieces of that complexity and trying to slap protections around them. So a lesson from here is when you're building abstractions, using abstractions, do it cleanly, not in a way that everything interacts with everything because that actually doesn't reduce complexity, it increases it. So the final piece is on bug reports. This was also quite interesting to see. So bug reports may be misleading. So the cycle would be somebody reports a vulnerability and they explain what this is about. Then it's consumed by the team who writes its own advisory, and there is a CVE record that has that. So this is an interesting example with remember that you can create a file by running a public constructor. In the report from the researcher, it was explained as arbitrary file override. Right? Sure, that's a thing that can happen, but this is not the problem. It's you can run public constructors. So you can do pretty much anything that is available as a public constructor, including writing files. But this bias in the description propagated into this other public information. So when you go and look at what is this particular vulnerability, you will see, oh, there is a file overwrite. And maybe you can see, well, it doesn't really matter to me because my application runs in a container with read-only file system. I don't have to fix it. But no, this vulnerability is not about that. It was just an example that was chosen in that report. It's important to know, like when you're making life or death decision about like a particular vulnerability, don't assume that everything that is written there is actually correct. It probably is most of the time, but there were examples when it's not. Another kind of interesting thing here is that this thing about like Unicode replacement and setting context variables, that was reported multiple times. It was the same vulnerability with the same impact that could be exploited in the same way. There were just like slightly different attack vectors because there was like ways of bypassing that filter. But this was always reported kind of slightly differently as there was more understanding. And the score, the CVSS score of those vulnerabilities was different. It was all the way from 5 to 10, 9.8. And this was kind of interesting because this was really mostly how things were reported that impacted how they were rated, not how the actual vulnerability worked. So only after the final, well, the third about that vulnerability was reported, it had in the title or in the primary description, it allows you to execute arbitrary commands, and it bumped the score. So if you're looking at what was the middle one about, well, it was about the same thing, and it should have that higher score, but it didn't because it wasn't understood this way. And like when that understanding was available, even though it was there, maybe it was on the second one, it wasn't on the first one. Like nobody went and like bumped up the score of historic vulnerability because, well, I don't know why. But what we can learn from that is, again, those vulnerability records will work well in aggregation, but they are probably not a very good tool to look at specifically when you're looking at specific problems. So final thing, more human nature thing. When I was looking at the discussions of the development team and their approach to things, I noticed that they had completely wrong assumptions about what people understand about Struts. They had this assumption that people really well understand the security model they have chosen, even though it was a bit weird. They were dismissing multiple vulnerabilities, like the one that you can access inherited methods, for years, until the getClass showed up. It's like, oh, we didn't think about it either. But there was lots of wrong assumptions that were completely incorrect. They were very close to the problem, and they thought people knew all of those things. And like, surely people should be doing this, should be doing that. That's not how all the other people wrote their applications. So again, don't assume that others understand your security model, especially if it's weird. So to close, some highlights. Struts. Picking on Struts is easy, right? Especially in the hindsight. But that wasn't the point of this talk. Struts was groundbreaking framework that helped people write good applications, but they were also one of the first trying to do those kind of things and trying to build those abstractions. And there were mistakes that we can learn from. Don't do magic. If you're writing your application and you want, and it seems like, oh, this looks like magic, that's probably bad because people don't interact with magic very well. So think about clean abstractions. And don't assume that people will understand all the intrinsic nature of your model. Powerful tools, don't use too powerful tools for a simple task. There's no way to contain them, and especially not with string matching. Design change, the right time to change your design is now. There will be never a better time to do it. I know it's hard to do. But if you're thinking about, well, compatibility issues, disruption, this will only get worse. Bug reports, they can be misleading. maybe inaccurate. They work well in aggregation or just to point you to existence of the problem, but don't take them at face value to like decide whether something is worth fixing or not. If you want more about that, there's a paper I co-authored that discusses that in a bit more detail. And that's it. So thank you for your attention, and I will have some time to take some questions. Yeah. 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 So the question was, did it had to happen so they could learn? So yeah, I was thinking about that. So yeah, so nobody is doing things like this. I think this was my opinion was that at that time, people were really trying to model everything through object-oriented programming. People were trying to contain all sorts of problems into relationship between objects and inheritance and aggregation and all of that. And Struts was also trying to do that. It was like, oh, we have this problem of objects and stuff. Let's use methods and getters and setters and Java beans. This is not how we do things now. That was the core problem. It was like trying to hijack existing thing and like shovel it to fit the problem, but it didn't fit, and it resulted in this complexity and these problems. Yeah.
So yeah, I was just wondering. So at the time when the vulnerabilities came out, I remember in the company I was working with, we had an application of Struts construction, and we were laughing. We were saying, "Don't we have vulnerability?" So and we didn't know great. So was there that vulnerability in Struts 1, and
yeah.
how was it related?
Yeah, so the question was about relationship at Struts 1 and Struts 2. Struts 1 wasn't using all of this magic, but there were certain things there were, I think, like I never used Struts 1. I did use Struts 2, but I think eventually there were vulnerabilities to Struts 1 and there was no patches because nobody was fixing that. So that's the danger. I think there was another question, yeah?
Yeah. Would another way to characterize this be a fundamental misunderstanding of the principle of least privilege? Like, from my point of view, this looks like it was literally designed for remote code execution. Like,
yep.
Literally. I mean,
yeah, it was. So principle of least. So this is probably what I try to contain in this picture with like, this is what can happen and this is what you need. We do that, like, this is very common in software where there's more expressive thing. It's like when people use HTML for formatting. Oh, I need to allow users to put some formatting. So they will use HTML tags and people put scripts, right? It's kind of similar thing. So it's not trying to take something very expressive for a very simple task and open it up and then trying to patch it around. Any other questions?
So, for example, if you inherited a legacy application built on top of Struts, that's what you have to deal with.
Yep.
How would you secure it? Would you put something in front of it to basically define what inputs you want, some kind of web application file, or anything else? What could you do? Maybe not to eliminate the risk, but reduce it.
Yeah, like, just the question was, if you already have to deal with Struts, what you do about it? Well, with Pain, you do all of this. So you cannot solve the fundamental problem. You have to rely on defense in depth. That's probably the best, and ask to migrate.
Maybe a silly question, but was it that popular, the framework, that they carry on? Even knowing that there is so many vulnerabilities, and just keep adding it.
Yep.
These pieces were really rubbish.
Yeah, it was very popular. It was extremely popular, and so you heard about Equifax hack. That was Apache Struts vulnerability. It was. There was no good fix. There was like they eventually. There's not that many new vulnerabilities in Struts, so this kind of works. But yeah, it dragged on for long, and yeah, it's very hard to migrate off a framework, especially if it's so like informs the design of your application. Okay, I think we are at the time. So thanks again for all your questions. and for your attention. Thank you.